Hello, in this video, I will explain to you on how to solve this problem. Let's read the problem first. In figure 5.43, a block B of mass M is equal to 15 kilogram. Okay, let's write that. So I'll have the mass is 15 kilogram and then hangs by a cord from a knot K of mass NK, which hangs from a ceiling by means of two cords. Okay, the cords has negligible mass and the magnitude of the gravitational force on the knot is negligible compared to the gravitational force on the block. Okay, the angles are theta 1 28 degrees and theta 2 47 degrees. And the question is, what is the tension in cord 3, cord 1, and cord 2? Okay, let's see it from the mass M. Okay, in the mass M, right? In the block. In the block here. And let's have our coordinates here. Maybe let's draw our coordinate first. Where is it? Okay, I will have the line here. Okay, let's draw it. This is the x-axis. And I will have the y-axis, right? Like that. Yeah, this is the x and y axis, and here we have the force by the weight of M downward, right? So we will have this force here, which is the force by the weight of the block B. But then on the opposite direction, we have the tension of cord 3 upwards, right? So we will have this one here. So this is, maybe let's name this T3, right? And then we can use the Newton's second law, right, to do analysis on this block. So we will have the Newton's second law here. Sigma F is equal to the mass times acceleration. However, it is not moving, right? So we will have the acceleration is equal to 0 because it is not moving or stationary. Okay, but then on the positive direction, we have T3 here. So we'll have T3. And then on the negative direction, I will have the force by the weight here. So I will have minus Fw. And all of that will equal to 0. Okay, and so we can move this force by the weight to the right hand side. So I'll have T3 here is equal to Fw. But then the force by the weight, we can also just use the formula of the mass times gravity, right? We know the mass, which is 15. Okay, so we'll have T3 is equal to 15 times the gravitational acceleration, which is 9.8 meter over square second. So we will have our value of T3 here. And I think we will use calculator for that. We will have 15 times 9.8. And I will have 147 Newton. 147 Newton. And that is for T3. Okay. And I think for the next question, we need to move this coordinate here into knot K. So first, let's erase this. Okay, for the next question, we need to move our point of view to the knot K. So we need to use the Newton's second law, but this time at knot K. Okay, let's see here. Here we have T3 here, but this time it is pulling this knot K down, right? Because we have the mass M here. So we will have the first force here. This is T3 going down. So we'll have T3 here. Okay. But then it has some angle here, which is theta 1. And because this is the ceiling and it is in parallel with this one, we can have this theta 1 here is also in this angle here, right? Because this is an opposite. Okay. And then this one here is also theta 2 because that is an opposite angle. Good. But then we can decompose this tension here in cord 1 and cord 2. So the tension is going here. Maybe let's draw it like this. And this is the tension on cord 1. Let's name that T1. Okay, maybe let's make it longer. So I make it longer here. So I have some space, right? Okay, and let's name this T1 here. And then let's use another color. Maybe let's use blue here for the tension on core 2. Like this. So let's name this is T2. Make it longer. Yeah, make it longer. Okay, we'll have T2 here. Okay, we can break it down into the X component and Y component for T1 and T2 here. Okay, let's do that. For T1 here, let's project it here into T1, X. T1 on the X direction. Okay, so that is the force on the horizontal direction. And on the vertical direction here, I will have T1, Y. Okay, and we also have T2 here. On the horizontal direction, I will have T2, X. Okay, T2, X. And then on the vertical direction, I will have T2, Y. Okay, we'll have T2, Y. Okay, and let's do some trigonometric here. So we will have T1 on the X direction, T1 on the X direction, and that will equal, okay, let's see here, this is theta 1, and T1, X is the adjacent angle, right? I mean the adjacent side, and T1 is the hypotenuse. Adjacent divided by hypotenuse is just cosine. So I will have T1, X is T1 cosine theta 1. Okay, and then on the Y direction here, it is the same actually. We have this one here, but that one also this one, which is the opposite side of the angle. And so we will have T1 is sine theta 1. Okay, and we can play the same game here for the T2. So I will have T2 here on the X direction, T2, X. We will have T2 cosine theta 2, right? So we will have this. This is the adjacent and this is hypotenuse. So I will have T2 cosine theta 2. But then for the vertical direction, T2, Y, we will have T2 sine theta 2. Good. Okay, now we can use the Newton's second law in the x-axis and also in the y-axis. Okay, let's do that. So here we will have sigma f on the y direction first. Okay, let's do that. So I will have sigma f on the y direction here. That will equal to the mass times acceleration. But then because this is stationary, on the right hand side we will have equal to 0. Right, that is because stationary. Okay, so on the positive direction I will have T1, Y, and also I have T2, Y, so plus T2, Y, and then on the negative direction I will have T3, so I have minus T3, and all of that will equal to 0. Good. What is T1, Y? We will have T1 sine theta 1. So I'll have T1 sine theta 1. And then plus T2 sine theta 2. And then minus T3. And all of that will equal to 0. Good. What is T1? T1 here is unknown and sine theta 1. So I will have sine, what is theta 1? 28 degrees. So I'll have T1 sine 28 degrees, and then plus T2 sine, what is theta 2? Theta 2 is 47 degrees. So I'll have 47 degrees. And let's move T3 to the right hand side, so that will equal to T3. But T3 is 147 Newton. Okay, and what is sine 28? Calculator doing that, right? So I'll have sine 28. Okay, and I will have 0 0.47. 0 0.47 of T1. Okay, and then we will have plus here sine 47. What is sine 47? We'll have 0 0.73. Okay, so we'll have 0 0.73 of T2, and that will equal to 147. I think nothing that we can do from here. Let's set this as equation number 1. Good. Now let's do it on the x direction. Okay, now let's do the Newton's second law here on the x direction. So sigma fx is equal to mass times acceleration. However, because this is stationary, on the right hand side we will have 0 here. Okay, and then here on the x direction we will have t2x on the positive side. So we'll have t2 comma x. T2 comma x, and then on the negative direction I will have T1 comma x. So we will have minus T1 comma x, and that will equal to 0. Good. Now let's put this here. So we'll have T2 comma x is T2 cosine theta. So I'll have T2 cosine theta 2, and then minus T1 here. So I'll have T1 cosine T1x, right? T1x, yeah, T1x is T1 cosine theta 1. Okay, and all of that will equal to 0. Now let's plug that in. So I'll have theta 2 is 47 degrees. So I'll have T2 is cosine 48 degrees. And then minus T1. Okay, T1 is unknown. So T1 is unknown, but we will have cosine of theta 1. Theta 1 is 28 degrees. So I'll have 28 degrees. All of that will equal to 0. And maybe let's calculate the cosine here on the calculator. So I'll have cosine, not 48, that will be 47. What I'm thinking, cosine 47 degrees, right? So I have cosine 47, and I will have 0 0.68. Okay, so I'll have 0 0.68 T2, and then minus cosine 28. What is cosine 28? I will have 0 0.88. 0 0.88 of T1. And all of that will equal to 0. Okay, maybe let's write the T1 first. So I have minus 0 0.88 of T1. And then plus 0 0.68. Yeah, 68. 68 of T2. Okay, all of that will equal to 0. But then we can save this as equation number 1. Okay, let's see here. We have 2 equations and 2 variables, right? Because this is T1, T2, this is also T1 and T2. We should be able to solve this using linear algebra. Okay, let's clean this up and solve this equation. Okay, the fastest way to solve this equation here is by using calculator, right? Oh, this is not T3, but this is T2. I think that will be T2, right? Yeah, that will be T2. Okay, the fastest way to do this is using calculator, and let's set this up. So equation solver is number 5, and we have 2 variables. Number 1, And let's plug that in. I will have 0.47 and then 0.73, and that will equal to 147. Good. And then we will have minus 0.88, and then I will have 0.68, and that will equal to 0. Okay, so we'll have the x value that will be our T1 here. So T1 is 104 Newton. T1 is 100, or maybe I will write it 103.9. 103.9 Newton. And what is T2? T2 is the y value, right? So we will have 134.5. 134.5 Newton. So that is the answer. Here, this is T1 and this is T2. Okay, so the answer for the question A is this one. And the answer for the question B is this one, right? It is the tension in chord 1, and the answer on the question C is this one here. Hopefully, I did not make any mistakes during my calculation. Thank you for watching. See you in the next video. Bye-bye.